This is Raspberry Pi networking. What can it do and why do you want to do it, which are the key things. Can the mouse click take you to the next one? Yes, it does. What can it do? Anything any other standard Debian Linux can do. Right, end of talk. Now that's a bit of a joke because the Debian Linux is quite often used for servers. In fact, its main use out there. It's also the base behind Ubuntu, the base behind Linux Mint, and all the rest of it. But Debian Linux is often used for servers, so it is just awash with a whole load of stuff. So the point of this course, or this little short talk, isn't to sit there and give you an in-depth analysis of all the stuff you can do, because that's like weeks of stuff. What I wanted to point out is what you can do, rather than talk about it much, each individual part much. What I did do though, when I was thinking about doing this course, I've given a really simple example of a configuration for each of them. So, and that would be a whole load of letter soup. Now some of you might recognise some of these and you don't, we'll go through all of these. DHCP is a dynamic host configuration protocol. When you put, say, your tablet or your mobile phone or whatever on the network here, DHCP is a bit where it says, where am I, what's my address, and how do I talk to everyone else? That's it asking you out. And you can actually run DHCP on the Pi. Fantastic stuff. Why? This is actually the really useful bit, because most home routers will do DHCP for you. In fact, they didn't, they'd be pretty useless. I use my own DHCP at home, because you know this thing, static IP address, people talk about having robots and having to sit there and specifically configure the address in, or putting up a little screen saying, my address is this. With DHCP, as it comes to the next bit, you can actually allocate a fixed address to a specific MAC address. So whenever your Pi turns up, it can have that address. So whenever this one does that, it can have that address. And in addition, you can also sit there and say, oh, and anyone else just grab an address from this pool. That's what's at that. The bottom line was apt-get installed, which installs software. ISC, which is Internet Standards Consortium, if I've got that right. They got the standard DHCP server. It's absolutely the same DHCP server used by the entire rest of the universe. You might be using it for a home network. That's probably the same software that does the DHCP for the entire Institute of Astronomy. It's used all over the place. That is the big giveaway page, actually. That probably tells you more than the previous one. This is an actual extract from my machine, from my configuration file at home. It's one particular entry. RasBMC. I've got a Raspberry Pi stuck to the back of my telly. This is genuinely true. I've got a nice big high-def telly, and I still haven't plugged it into the aerial because the aerial's in the other room. It's just got a Raspberry Pi on the back of it, and the aerial is in fact plugged into a high-def TV tuner, which is plugged into a PVR software, personal video recorder software. So the TV is recorded to hard disk. Who watches TV live, and then I sit there and watch it using the Pi from the hard disk drive. But I want the Raspberry Pi that's on the TV to have a fixed address. It just makes life easier. So host RasBMC, which is the machine that does all the TV stuff, which runs the RasBMC distribution. Hardware Ethernet BLA. That, for those of you who know, is like the MAC address, which is the low-level address of the Raspberry Pi. Whereas the first three say I'm a Raspberry Pi, and the second three are the serial number. Fixed address, BLA, option hostname, BLA. I don't actually need the hostname. But those two indented lines, sit there and say, this machine, whenever you see it, give it this IP address. Superb. On my file servers, a fixed IP address is blah, 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 blah. It just makes stuff so much easier, and it's that simple to configure. Again, if you Google DHCP, Debian server, bang, there's gazillions of configuration guides out there. I didn't want to go through hideous details of all of these because it would be days. And the things that this thing can do is ridiculous. You can set up multiple servers and they coordinate between each other in case one goes down. No one's going to need that at a home network. That's why I run my DHCP server on the Pi, by the way. I don't have multiple redundant servers doing all the clever stuff. I've just got a copy of the SD card, and if that particular one goes wrong, I just get another pie out of the spare pile, stick a copy of the SD card in it, stick it in the place where the other one was, and just power it on. It's redundancy with having a pile of pies in the cupboard. So that's very useful for configuring things like DHCP for robots, for really important things like media centers and other critical infrastructure components, like all the file servers, so you always know what they are. Any questions on that one, Bo? Yeah.
What do you do when you've got your DHCP server here running on a Raspberry, and you've also got your router on the network, also operating DHCP servers?
There's the right way of doing it and the wrong way. The wrong way is to do nothing, which basically hilarity ensues. The two fight, it doesn't end well. The right thing to do is to go to the one on the router and switch it off. Now you've got to actually sit there, part of the bit that's off the top of this screen, you have to sit there and say, on your DHCP response, you have to say, your IP address is this. Oh, and the router's over there, because the router's not going to tell you where it is. So you have to configure some stuff like that in, but that's reasonably straightforward. But most routers, in fact I think all I've seen, have an option to turn DHCP off, looking somewhere in their menus.
I would recommend that you don't do it at work.
Yes. If you start confusing DHCP addresses, it doesn't end well.
Especially people who are using VoIP for their phones in the building, that would be quite hilarious. That didn't happen in my place at all.
Yeah, I can see exactly things like that. This actually isn't a problem for me at home, for reasons I'll come to in a bit. I don't suffer from this one, I did not have to turn the DHCP off on the router, but we'll come to that in a minute. DNS server, which is domain name system. This is a system where basically it gives you, when you give it in a host name, it figures out where it goes. Allows you to add names for your local machines. That's it. So what it basically, the way I've done it, and in fact I'm doing it completely overkill in this, I figured out there's a much easier way of doing it. This is again the internet angles. Yeah, it allows you to add the names to your local machines, and if it doesn't know a machine, it says, and go and ask him. So this one, so any machine on my network says, where's Fred? And it goes and asks the client where Fred is. If it happens to be one of my local machines, it goes, yes, it's over there. If it doesn't, it then goes ask the router, who goes ask, who goes ask, who goes ask. So it just passes it on the chain. This one's got a slightly more complex configuration, but this gives you the idea. There's actually some quite complicated modelling because this server is so stupidly over the top it can handle just about anything, which is why this is in fact the wrong server to use. Because there's a much simpler one, which I cannot remember the name of, but I haven't just got into this much yet, which just takes DNS, does a very, very simple check, and then passes stuff on. So it only does local names. This particular one I referenced on the previous slide, which I can't go back to because I haven't got a keyboard plugged in, which is the full-on, I'm the mega industrial super version, I can run an entire network. It's the huge, big production one. This is what the file looks like. In fact, you actually only need the first line. The first line says, if someone asks for Raspberry MC, it has an internet address of 192.168.2.91. The other 4 lines are me basically playing with the system. The second line, some of you might have noticed, is an IPv6 address because my home network is also IPv6. The third line is something that approximately nobody uses, but I just wanted to see if it worked. You can put an entry in the database to describe that particular system. Only Raspberry Pi 2, that really dates it. And then the last 2 entries are actually aliases if I want to force it to talk via IPv4, if I want to force it to talk via IPv6. So it's actually got 3 names there, of which the first one has an IPv4 and an IPv6 and a description, and the second, and Raspberry MC4 just has an IPv4 address, and Raspberry MP6 just has an IPv6 address. This is quite a complicated one to actually set up because I went and used a full mega industrial. I'm deploying this for an entire nation level of software, which is just complete overkill. Anyone remember the name of the really small ones? You might know and use it. There's a much simpler version that I need to find, which is saving me a lot of faffing around, because this is actually quite a beast to
A
configure.
smaller version of Bind.
Yeah, this is actually Bind 9.
Yeah.
Which is the huge, big, there's a one that's cut down, because this, 99% of users aren't ISPs. They're actually people who just want to know the machines in their house. But someone's done one which is much simpler. It just gets DNS, goes, is it one of mine? Yes, no, pass it on. This one says, right, is it in this domain? Is it in that domain? Check it in this domain. It does a whole lot of branching stuff, so you could serve all of .net, .ac.uk, .co.uk and .com from your Pi, at least theoretically. It's that level of stupid over-the-topness. You could probably Google to find out the simple one.
Mara DNS? A
Possibly.
small open source DNS server.
That doesn't ring a bell.
DNS Mask?
That's the one.
That's the one, yeah. Yeah.
Which is a DNS masquerade.
Yeah.
So it says, yes, I'm really a DNS server. Actually, I'm not online. And it just passes things through it. Then it goes like, aha, no, that one. So it's a masquerade. It's a DNS pretender, which is much simpler than this, which is a full industrial thing of great evil. Actually, it is incredibly powerful, but don't assume it's easy to use. So, any questions on that one? DNS Mask, that was it. SSH. Secure shell, if you actually want to do a command line log into a remote machine. Now, I do this because there's sometimes, actually, I'll just run through this first. It allows you to remote log into a Raspberry Pi, always useful. Before you do this, change the Pi login's password. Otherwise, you have people from all over the world logging into your Raspberry Pi, assuming it's on the internet, on the outside facing stuff, which we'll come to in the final part. Better yet, remove the Pi user. My bit that's the guiding, which we'll come to next, the actual firewall, does not have a Pi user on it, just to make absolutely certain. Only then you can forward a port on your router to the Pi. And personally, I only allow public key access because it gets to be quite complicated to secure remote access. They've got SSH on the Pi, you might have used that to remote login, got for headless operation. I've got this set up at home because sometimes something really critical, like you're on holiday and you realise you forgot to set one of the PCs to record Doctor Who, going back to using the media centre. I can use this to remote log in up to home and to program one of the machines at home to record Doctor Who. So it's absolutely critical functionality. You want it secure, you don't want anyone else mucking up your video recordings, blah, blah, blah. So another page on that one. This is again, you can see the Pi, again, if you look up SSH configuring, it's actually quite complex to get the full thing going, but it's there and you can do it in these tutorials. There's a lot of material out there. I've got an example of that. This is the other one. Now, I mentioned earlier about the whole, this is the most complex of the lot, about the DHCP not being a problem. I should have put a Dargo in here, so I shall go to chalk. Let's go retro. My Pi that does all of this is actually quite unusual. I've got the whole Internet of Evil here. That comes in as a classic home router. I've then got the Pi here. That's not too bad. This is the key thing. I've actually plugged in a second USB Ethernet port onto my Pi. One of them goes this way, and that's the, we actually call it, the correct name is a DMZ, or demilitarized zone, which is, this is the, behind the, this is your home router, the one that actually comes from your internet. Here's the Pi. This is the untrusted network on this side. Oops. And here's proper home network. This is home. This is the trusted network on this side. This is why I didn't need to turn DHCP off at home. The router does all DHCP on this side. this is like evil and untrusted. All the stuff that's actually on my real network at home, all good here. So the DHCP only looks this way from the Pi. It's set up to ignore any DHCP requests on this side. But this is where all the evil, untrusted nonsense is. This is where it's all actually trusted. Now, there's a thing called IP tables inside Linux, which is a hilariously complex, convoluted, you wouldn't believe how easy it is to get wrong system, which provides a series of filter rules. The first thing you need to understand is that the Pi can be told that if someone on here asks something out here, or indeed let's call these, got A and B, actually you have to see out there on the internet, you can tell the Pi that if someone on a trusted network wants to talk to the internet, fine, let it through, we're good to go. But if someone on the internet wants to talk to just anyone at random, wants to talk to one of my machines here, like no. There's a whole series of rules you can actually set up. It's notoriously complicated and difficult. But then it's useful. I want to be able to log in. So that's what I said earlier. We can route the SSH from the entire world and get put into here. So I said SSH is, whoops. The router is configured to let SSH through to the Pi, for example. So that is how I can go in and then actually jump through the Pi to the machines at home. It's double security. You can allow some things in, but that's one of the very few things I allow in. But you want everything to be able to go out. And there are all sorts of complicated things about the handle, especially things like VoIP calls and what have you. But there's a thing called Shorewall, which makes life a gazillion times easier. Again, there's lots of tutorials on the internet about this. Let's actually look at examples, sums it up. You have zones. The first three are actually the key important ones here. The firewall is the firewall itself, i.e. the Pi. Evil is what I've called the entire rest of the internet. That's everything. So I said, this is me. I'm the firewall, actually called FW. It saves a lot of typing later on. We've got evil, which is everything to this side. And we've got the house, which is everything to this side. That's fairly straightforward. So like, right, okay, evil's runs IPv4, house runs IPv4. They're just standard internet. The firewall is the firewall. I'm going to drop things. I've also got VPN and IPsec. If you don't know what those mean, don't worry about them. If you do, it's like, oh, it does that as well. That's got to do with putting remote machines on my network at home, which has got absolutely nothing to do with letting people play my music and me playing their music. But we've got basic network joins in my house and a friend's house, so networks joins. So that's fair, zones, you can understand zones. Interfaces, well, what's where? That's quite easy. On the Pi, Ethernet 1 points this side, everything on that side is evil. Ethernet 0, which is the one that's actually on the Pi, points this side, that's the house. Oh, and by the way, we're running DHCP on it. Fairly simple. So we've actually said what zones we've got, we've given them names, which zones are on which interfaces, all well and good. Then we have rules. Accept stuff coming from evil to the firewall if it's talking TCP on port 22, which for those of you into this sort of rubbish will know is actually SSH. So that first line says, let SSHs come in for the home router. Home router's forwarded it to us, and rather than going like, no, sit there and say, yeah, okay, we'll allow that. The other two, UDP ports 500 and 4500.
Pike and...
You were really close.
Pike, and then you've not got IPsec, because IPsec isn't IPsec TCP 5000.
Yeah, it's because it is IPsec, but it's IPsec inside UDP because it's
you're
got...
because you're encapsulating.
Yeah, you have to map reverse the router as a problem. Yeah, so that's why it's IPsec inside UDP, which is what those are. Right, those of you who want to know what that was about, that's how my Pi whilst going through the router, can talk to my friend's router with his pi over here, and that pi is to go through that router, through the internet, through this router to this pi, which is actually quite complex. Well, it's not that complex. But it changes all the addresses. It was like, hi, it's me, are you sure you're you? Yes, prove it, okay. We also do this huge handshake which proves who you are, then we negotiate how we're going to talk to each other securely and blah, 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 blah. So the bottom one are accept anything coming in over that connection to the house. In fact, you actually have to put it through twice. Because it comes in, yeah, I know this is way too often. It actually comes in on a secure connection, and we accept that into the pi. It gets decrypted, secured, verified, and it has to go through the pi again, because then it goes back out to the house. So we can accept from the VPN to the firewall, and accept from the VPN to the house. So that's incoming connection. So yes, my mates can talk to me. So those are the actual rules we have. Those are almost like the exceptions, is almost in the wrong order. So those are the rules we have, but there's actually policies, and the rules are basically exceptions. The policies makes an awful lot more sense. Anything going from the house to the evil internet, yeah, that's fine. Anything going from the house to the firewall, yeah, we'll accept that. Anything going from the firewall to anything in the house, we'll accept, because that's an incoming connection coming through. From the VPN to the firewall, we'll accept, and from the VPN to the house, we'll accept. So that's so you can sit there and do all the file sharing, not file sharing, VPN networking. So that means that I've got my network here, and my friend's got his network here. That's basically VPN also that it comes from his network, secured, encrypted, unencrypted, blah blah blah. Can talk to any of my things. The last two lines are perhaps the key. Anything coming from the evil internet to anywhere that we haven't already mentioned, throw it on the floor, drop it. So you don't even sit there and go on your bike. I just drop it. I don't even respond. Don't even bother arguing. Just drop it. But info means and report it. So you've got these incoming messages like, hey, someone's trying to hack into you. So if any message comes in from here, so it's basically from the evil internet to anywhere at all, don't care where it is, it will just throw it away and report that someone's trying to break into me. Which happens about every 5 seconds, so you've actually got to have log file compression turned on. There's a surprising amount of rubbish out there. The final one on the bottom is if you really haven't caught anything so far. That means that something's gone wrong, so that should have caught everything. So at the bottom, anything going to anything else I've forgotten to do, reject it, which is different to drop. That means like, no, go away. You actually explicitly reject the connection, which is useful for debugging, and you report it. That is quite complex. There's a whole load of tutorials out there, I'm sure. But this is getting way over complex. It's really quite sophisticated stuff. But it's fun playing with. It took me weeks to get this right. The VPN stuff was absolutely horrible to get right, by the way. Really evil. Else? There's loads of other things. Yes, there's all the VPN software, which is virtual private network, so that we have what appears to be my house directly attached to my friend's house, but it's actually another one, that we all appear on each other's networks, which is very useful. Web servers, always good for a laugh. In fact, this is another good reason for a Pi. One of the things I actually want to set up, which brings back this untrusted network. I want to put my web server here, and it's going to be on a Pi. I'm going to plug it in to the home router there. The reason being, if it's a web server, it's going to pitch into it. There's no point. No, you can just have an internal one, but if you want an externally visible one, I'm going to have it here, so that if it gets compromised, if someone is able to take over that web server, because it's running Apache or whatever this week, if someone takes it over, I lose the Pi, and nothing else. If someone owns that machine, they can't get through. This is still protecting me. This is why I've got so many Pis, by the way. So that is basically sacrificial. If you follow the rules on previous slide, I can talk through to the web server, no problems. That's it, just on my pages. It can't talk back. So if this machine gets broken, remix the SD card and we're back. After whinging Michael. And there is infinite mountains of other stuff out there. Absolutely mind-numbing amounts of stuff. Got any questions at that point? Yes.
What do you have any Windows-based VPN software for remote access that you've found works to make it fit?
I don't use Windows, so
Yeah, I
I
knew you'd say
don't
that.
know. If you look, actually, what's the VPN system I use? Oh, I can't even remember the name of it now. If you look, there is some stuff that will talk through the whole IPsec stuff often works, but a lot of people report problems with it.
Yeah,
OpenSwan, right, there's three of them.
Swan.
Just to confuse everything, there was a huge, massive war between the various parties. There was FreeSwan was the first, which is some basic stuff. And someone said, I want to pep this up a bit, and they did OpenSwan. The original FreeSwan people, SWAN stands for Secure Wide Area Network. So it was the original OpenSwan, which allowed you to talk, and it was pretty much standards based. Well, they all are actually. There was the original one, and they wanted everything on the internet to be encrypted, but it didn't quite work out that well. So they basically got bored and gave up. So the FreeSwan people forked the code and added it to a bit, but they were quite careful, fully standards based, blah, blah, blah. And someone else came along and said, no, you're not running the latest super mega secure protocol, so they use something called StrongSwan, which supports IKV2. You know, yeah, okay.
But nobody uses it yet.
Actually, I do, mostly because they're...
You would.
Well, one, I would, and two...
None of my customers do.
Your customers do?
Well, kind of. None of the customers that look after themselves do. The customers we manage do, because we put it on for them.
The key, because it's high communication,
Yeah.
we're all running StrongSwan, and it does all crypto magic. Anyone knows how to get StrongSwan to talk to FreeSwan, I would really love to know. I cannot get it to work.
Sometime,
Because it's different. One uses Pluto, the other one uses something else. I've never sussed it out. It's just hideous nightmare of nightmare. It's truly horrid to get that stuff working. I tend to just use tunneling over SSH, because I'm basically like, because we're basically lazy.
Sorry, you said that to SSH anyone could get into your Pi. Is that because you need to have an SSH server enabled in your Pi?
Yes, you need to have the SSH. Sorry, that was a bit of an over-exaggeration.
It's enabled by default.
Yeah.
It's open by default. What isn't open by default is it passing through your home router. That's not open by default.
Is there one a setting of the SSH server? Or?
Yeah, you can turn the SSH server on the Pi on and off. I think it's on by default.
Yeah, it is in the configuration, the initial configuration wizard, that big blue screen. You can turn it on in there, can't
But
you?
you can-
Nice and easy.
By default, you can SSH into a Pi on your own network, but home routers don't come with it enabled by default. You actually have to turn it on. That's why I was quite... Can I go back?
So it's a router setting, not a Pi setting.
Yeah, it's the router setting. Yeah, that's the one. That's why. And the third point, only then forward a port on your router to the Pi, then you can remote log in. So what I have is that if this home router sees port 22 coming in, I've got port forwarding turned on to the Pi. But do not do that until you change the user and password on the Pi. People sit there and try it. It's interesting to watch because I sit there and see in the log file people try to log in as root, people try to log in as debug, people try and log in as test, people try and log in as guest. It's quite fascinating to watch.
You can set up certificate keys. So you on the Pi itself, there's a whole bunch of stuff, and you end up basically with a key each, and you keep one on the machine you're connecting in with, and they check each other. And
That's exactly what I do.
Typically,
And then that way,
typically a router would not allow that sort of
oh, typically no.
unless you
have to go and manually
modify the
configure
router
it.
settings.
Yeah, you have to go in and tell
I
it.
just wanted to make sure.
Yeah.
Not quite scared that you want to log into it.
It's fine. This is why, before you turn that port forward and over, before you open the door, make sure you've locked the other door. Because otherwise it's not going to end well. Actually, what I might do, for a laugh, is put a Pi, because hey, no, we've all got piles this high up covered. Put a Pi on there, change this port forwarding to make it, I don't know, 1, 2, 3, 2, 2, goes into that Pi, and make port 22, the original SSH, go through to this Pi, and not change the password. Then just walk away. So that Pi's there, it's open, I've deliberately not locked it down, and see what actually happens.
Honeypot.
Exactly. Leave it, because if someone takes that Pi over, who cares? It's just a machine consuming very little power stuck under the stairs, together with the other machine and the other machine. This is actually the big plus about Pi, so you can play with it. Sorry.
That's a different question. I don't want to interrupt what you're saying just then.
I've just finished the...
Oh,
Nicky, make this the last question.
Okay.
if you get a load of Pis in a room and they've all got Wi-Fi dongles, but there's no router in the room, is it possible to set up some kind of network so that you can SSH into those Pis?
Yeah, there's some, we came across this, there's some software you can get that makes the Raspberry Pi act like an access point.
Really good one on the Adafruit website.
Yes, that one. That also gives you Tor as well. Or is that different?
Yeah. No, that's a different one. Oh, well, pass.
Yeah, there's a really good guide on the Adafruit website.
I know there's a teacher in Southern British College who's turning one Pi into an access point, and all of the students are connecting into that when they turn their Pis on. So doesn't have to worry about the cabling for the networking to do it. So it's called James Robinson. He's really good stuff. It's really cool. Check that out because he's doing that last week. So, yeah.
That actually quite, because I'm again feeling completely and utterly paranoid, I don't actually have Wi-Fi at home, but I'm thinking about putting it in, but I'm just going to assume that the Wi-Fi is cracked, that someone's... Yeah, I know. Welcome to paranoia.
Tinfoil hat.
Absolutely. So I'm going to put my tinfoil hat on and have, guess what, another Pi, acting as with the Wi-Fi symbol, whatever, I don't know, with an arrow on the side of it, and that's plugged into that. So the Wi-Fi goes into the untrusted network side. Then of course you can have with your security keys go back to the first Pi. This is actually, all joking apart, Pis are cheap enough that you can actually play model networks with them. And if you're actually teaching networking and you need, say, how many Pis have I drawn on there? There's one there, 2, 3, 4, and there's a TV on there, it's 5 Pis. Yeah, you can get 5 Pis for a reasonable price, and you can actually play with this stuff and try it out, and that's actually a big plus. But any more questions? I think I have to go and grab me afterwards, or grab me now, rather. And see, you can do presentations on the Pi. Anyone tells you you can't, they're lying. I'm looking at you at the back there. Actually, you do.
No, he's just after his keyboard and mouse. So he's
Harsh. And whose power supply is it? Because he's got my tongue.
My power supply. Yours is still at the roof.
Right, okay. Thanks a lot, folks.